Hey everyone, in this video we're going to learn how to solve absolute value equations. To start us off, evaluate each of the following. We have the absolute value of 6, which is equal to 6, the absolute value of negative 6, which is equal to 6, the absolute value of 0, which is equal to 0, and the absolute value of negative 4.1, which equals 4.1. So the point of emphasis with this exercise is that when we evaluate an absolute value expression, our answer is always non-negative. So why is that? Why is it that when we evaluate the absolute value of negative 6, we get positive 6 out? Well, why is the absolute value of a number always non-negative? Well, to answer this question, let's look at a number line. And I'm going to put 0 in the middle of the number line, and I'll use the first two examples. So I'll put 6 and negative 6 on our number line. So if I asked you to figure out the distance from 0 to either 6 or to negative 6, your answer to both of those questions would be positive 6. Right here, 0 to 6, that would be a distance of 6 away. And then from 0 to negative 6, that would also be a distance of 6 away, just in the other direction. And the absolute value represents the distance from 0. So the absolute value is the distance from 0, which is why it's always a non-negative number. Following it up, absolute value of 0 was 0. Well, that's because it's exactly a distance of 0 away from itself. And that's why we need non-negative and can't just say positive. So for what values of x does the absolute value of x equal 10? Well, if we think of this intuitively, if we input 10 in, absolute value of 10 is 10. So x could be 10. So that's in the positive direction. And think of a number line, if we go 10 in the negative direction, we'd get x equals negative 10. So our solution set would be negative 10 or positive 10. Both of these values, if we input them into the absolute value, we would result in 10. Now let's formalize this idea a little bit more. So if the absolute value of x equals a positive number, then either x is equal to the positive number or negative x equals that positive number. So essentially what this is saying is if absolute value of x is a positive number, either the input could be positive, so x would be the positive number, or the input could be negative, and we'd have to negate the input to get the positive number. Now let's look at this with some actual values to make sense of it. So solve each of the following absolute value equations. So first we have the absolute value of x equals 4. So we're going to set up two equations. So either x equals 4 or the negation of x equals 4. And we'd have x equals negative 4. Now I know some of you are looking at this and saying, well, can't I just get that the same way we solved the last example? Just think of it intuitively? And we can. But as these equations get harder, having a method to apply is going to be really beneficial to us. So here our solution set is negative 4 or 4. Right? If 4 is the input, then the positive 4 is equal to positive 4. If our input's negative 4, mathematically how we make it positive is we multiply it by negative 1. That's what this is saying here. Mathematically, we take a negative input and turn it positive by multiplying by negative 1. So absolute value of x equals 0. So either x equals 0 or the negation of x equals 0. So this would also be x equals 0. So in this case, there's only one solution, and that solution is 0, which again should make sense. Absolute value is a measure of distance. The only value that's 0 away on the number line is 0. And then we have the absolute value of x equals negative 2. Well, if absolute value is a measure of distance, and distance is always positive, then it will never be equal to a negative value. So here we have no solution. If we don't recognize this, then we are going to be able to set up the equations and get answers out. Okay, we have to understand that there is no solution because we can't output a negative number when evaluating an absolute value. So now stepping into some more complex equations. So solve the following absolute value equation, which is the absolute value of x plus 11 equals 15. Okay, so we're going to say x plus 11 equals 15. So if the input is positive, then we just leave it alone. And if this input is negative, we have to negate it. So the negation of x plus 11 equals 15. And we want to make sure that x plus 11 is inside of parentheses. So we'll solve x plus 11 equals 15 first. So subtract 11 on both sides. We'd have x equals 4. Now here we can either distribute the negative or we can divide it to both sides. In this first example, I'll distribute it out. So we'd have negative x minus 11 equals 15. So negative x equals 26. So x equals negative 26. So our solution set is negative 26 or positive 4. And we can easily check this by plugging both of these values in. Same directions, new equation, which is the absolute value of 2x minus 1 equals 9. So we'll start, if the input is positive, then we just leave it, so 2x minus 1 equals 9. And if the input is negative, we'd have to negate it, multiply by negative 1. We want to make sure 2x minus 1 is in parentheses. So here we're going to add 1, so 2x equals 10. Divide by 2, x equals 5. Now in this case, I'm going to divide both sides by negative 1 first, just to show you an alternative way instead of distributing. So we'd have 2x minus 1 equals negative 9. Add 1, so 2x equals negative 8. Divide by 2, x equals negative 4. So our solution set is negative 4 or 5. Now a lot of times people will start just 2x minus 1 equals negative 9. But I like starting here because it really emphasizes the idea of the absolute value. If the input's positive, it stays the same. If the input's negative, we have to multiply it by negative 1. So we really get a better understanding of an absolute value. Okay, so now turning to a quadratic, solve x squared equals 16 by factoring. Well, if we're going to solve by factoring, we need the equation equal to 0. So x squared minus 16 equals 0. That's by the zero product property. Next, we can factor x squared minus 16. So x minus 4 times x plus 4 equals 0. So then we would have either x equals 4 or x equals negative 4. Okay, so our solution set would be negative 4 or positive 4. Now it says solve x squared equals 16 by creating an absolute value equation. Okay, well, how are we going to do that? Well, x squared equals 16. The only other way I can think of approaching this problem is by taking the square root of both sides. So the square root of x squared, well, I think that's x. Square root of 16, that's 4. But I know I should get the answer of positive and negative 4. Well, I could just throw a plus or minus in front of the 4 and say, okay, there I have it. And oftentimes that's what a lot of people do, but we're missing a really key fact. What this really should be is this should be the absolute value of x equals 4. And I'm going to put a star next to this. And this is a really important fact. The square root of x squared is really the absolute value of x. Now we can say either x equals 4 or negative x equals 4. And that would give us x equals negative 4. And now we have both solutions of negative 4 or positive 4. Okay, so if we're going to choose to take a square root of both sides of an equation, we're really turning it into an absolute value equation. And that's how we're going to tie quadratics to absolute value. So an important mathematical fact is the square root of x squared equals the absolute value of x. So when solving a quadratic equation by taking the square root of each side, we turn it into an absolute value equation. So solve the following quadratic equation by rewriting it as an absolute value equation. Okay, so we're going to start by taking the square root of both sides. So we have the absolute value of x equals 1. So that means either x equals 1 or the negation of x equals 1, and that means x equals negative 1. So our solution set would be negative 1 or positive 1. This is the best way to solve these. Instead of just remembering, oh, I have to put a plus or minus to get both answers, right? That misses all of the math behind what you're doing. Okay, so when we take the square root of either of both sides of an equation, we want to turn it into an absolute value equation. That's the point of emphasis here. So solve the following quadratic equation by rewriting it as an absolute value equation. And the equation is x minus 7 quantity squared equals 64. So what we're going to do is take the square root of both sides. So that means the absolute value of x minus 7 equals the square root of 64, which is 8. So that means either x minus 7 equals 8, or the negation of x minus 7 equals 8. So if we add 7 to both sides, we'd have x equals 15. Here we'll distribute the negative. So negative x plus 7 equals 8. So negative x equals 1. X equals negative 1. So our solution set here is negative 1 or 15. And we can very quickly check that. Negative 1 minus 7 is negative 8. Squared is positive 64. 15 minus 7 is 8. Squared is also 64. And our last question, same directions. X plus 2 quantity squared equals 81. So we're going to take the square root of both sides. So we have the absolute value of x plus 2 equals 9. So that means either x plus 2 equals 9 or the negation of x plus 2 equals 9. So here we can subtract 2 from both sides. We'd have x equals 7. In this case, instead of distributing, I'll divide by negative 1 just to show the other way to solve this. So x plus 2 equals negative 9. Subtract 2 from both sides, x equals negative 11. So our solution set is negative 11 or positive 7. Quick check, negative 11 plus 2 is negative 9, squared is 81. 7 plus 2 is 9, squared is also 81. So we started with absolute value equations, and we worked into the fact that when we're solving an absolute value equation, we want to take the input, whatever's inside the absolute value, and set it equal to the output. Okay, in this case, it's 9. And then we want to negate what's inside the absolute value and set it equal to that same value, in this case, 9. And then we solve each of the equations that we set up. Okay, so we should always be setting up 2 equations when we're solving an absolute value equation. And then we connected to a quadratic by the fact that when you take the square root of x squared, it becomes the absolute value of x. And then we've created an absolute value equation that we solve the way we just spoke about. Okay, so practice with a few of these before heading into your next video. Click the Amazon link down below for my algebra workbook so you can practice on your own. Give the video a like, and before you go, click that subscribe button so you can see more videos just like this. Thanks for watching.